Hi guys, I hope you are doing well. Welcome to my channel. In this clip I want to introduce a solution to having these kinds of trains with realistic high maps and topographic and satellite images as a textures, and also the realistic trees or buildings or constructions, everything 3D scanned objects of the real world in Unity. It is a Vancouver city, but it is fully global, so I can even go through other cities, other countries, other continents, and have the same quality for the whole train, and it is very optimized. And so you can use this technique for your games, for your simulations or animations. Okay, let's do it together. Let's make a new empty scene over here. After that, we should go over this page on the GitHub. I will share the link of this package in the description of this video. It is Cesium GS. It's a great package. They made this technology for Unity, for JavaScript, for Unreal, or for other platforms, and you can use it for non-commercial purposes. It is free, but for commercial purposes, it's mandatory to provide your account. It is a subscription method, and you need to subscribe for them and pay the amount despite your plan. Okay, you just need to download the project by the download zip and open this project on your Unity editor. It can be any version, but it's better to use it with your newest version of Unity. For example, for me it is 2022.3.8, and after that, after you install your project, I propose to go over the player settings and assure that these kind of settings are checked. First, for the rendering, for graphics APIs, it's better to use Vulkan because it works better with the streaming system. Remember, this project, this technique, this solution works with fully online internet, and it needs probably high-speed internet, so provide it as an online solution. It doesn't work for offline. And after that, it's better to check the low quality for light map encoding and HDR cube map encoding. I want to emphasize that this technique works for URP and HDRP as well. And here you should check on these kinds of package names, and minimum API level. It's better to be 10 if you want to export for Android, for mobile APKs. And here IL2CPP for sure, and .NET 2.1, and faster runtime for sure. And here allow downloads over HTTP, not allowed. It is important. And here ARM v7 and ARM 64, both of them have to be checked. And here, this is important. Without this, it probably won't work. Internet access is fully required, not auto required. And write permission is internal. It can be external, but I propose to set it internal. And here something it's important, active input handling. By default, when you use their project, it is checked by set by inputs system package new, but I propose to change it to both. It will be perfect if you want to work with mobile platform and also PC at the same time. And after that, we should go over quality. If you want, it depends on your platform, target platform. For example, for me right now it is an Android, so I prefer to check down the performance. But if you want, you can use on high fidelity. Of course, it is more performance consumer, but it's more quality. But what matter is, if you want to export for mobile, you have to check render pipeline asset and set it equal none. But if you want to export for better devices, you can choose one of these render pipeline assets for your quality. And after that, you need to make sure these kinds of options related to shadows or anisotropic textures must be disabled, because on Android you don't need it. After that, we are ready to start working with this package. Until now, we have done preparation settings of the project itself. Okay, we already have an empty scene. Here on the top we have a Cesium tab, and if you click on Cesium itself, look at this, we will have something new here. There are a lot of options. Google photorealistic 3D tiles, or Cesium Word Train Bing Map aerial imagery, and Bing Maps aerial with labels, and also if it is for a roadmap. We will check them one by one. For example, I click on this guy, and now look at this, it works. It generates the whole Earth, and it's fully 3D. Look at this, and it is realistic. If you want, you can come up and see that it is the whole Earth. The funny thing is, it doesn't cache on your application. It is fully runtime. It means when you export from your game, for example from mobile phone, it will be almost 115 or 100 megabyte, not gigabyte. But you have the whole Earth for your trains. Look at this. And it's trying to make it as best as possible. For example, it is an airbase. Yeah. Look at this, it is beautiful. Now, it is for Google. Okay, let's remove it. We can have with Bing Maps. It's different than Google. The imagery will be different, the quality of images will be different, and also there is no 3D tiles on Bing Maps. So remember that. Look at this. The quality of Bing Maps is different than Google. Sometimes it's better, sometimes it's worse. But if you want to have only train without buildings, Bing's map can be better choice, better option for you. But if you want to have buildings, it's better to use Google photorealistic train. And also, as you can see, the quality of mountains in Bing Maps, it's almost smoother than Google. So it depends on your scenario, honestly. For example, if you click on with labels, you will see the train with 3D you know, high maps, but you will see the labels of the real map here as well. Look at this. It'll look like a 3D map. Look at this. So if you want to have a, you know, a 3D map, it is a great option for you. And here it is just road. It's not photorealistic imagery. Look at this. It's fully something like this. You will have a 3D map. And the last one is, for example, this guy. Look at this Cesium board train. It's a different satellite image provider, but the quality of it is low. Okay, so get back to that photorealistic Google from Google, and as you can see, we have our train, but we should have a camera as well. Remember, the method of this package is, if you want to move over the train, it doesn't move the camera, it moves the train itself. So let's remove the main camera here, okay? And come over the Cesium and select add dynamic camera. Okay, look at this, we have dynamic camera over here. Okay, and if I play, you will see something cool. It is a simple camera, but it has these 4 components related to Cesium camera. So you'll see you have rotation of your camera, and if I press W, go ahead, backward, left, right, E up, Q down. But look at the position of the camera, it doesn't move. In fact, we are moving the train, not the camera. With this method, we can fly, for example, 10,000 kilometers over the realistic Earth, okay, without going outside of the positioning system of Unity, because as far as you know, the positioning system of Unity is limited. You can't put an object in position of, for example, 100,000, 100,000, 100,000. For example, it will be out of the boundary of Unity. But with this method, we can go wherever we want. Okay? And now, let's take a look at some options of the the train itself. As you can see, the basic position of this train is here, but where is here? It's kind of nowhere, middle of nowhere. Okay, but I want to change that. When I want to start the scene, I want to see, for example, Paris. Okay, let's go over the maps. It's Google Map. Okay, let's go here. I don't want Vancouver. Let's go Paris, my favorite city. Okay, and select a position, a random location. Doesn't matter where example here. Okay, let's select this coordinate. Okay, copy as you can see it in this is two number. These are two numbers and they have separated by these comma. Okay, select the first one, copy, and go back to the Unity. Select the Cesium georeference. Okay, and in here, instead of latitude, we will paste that number. Okay, and come back to the map and copy this part again and paste over longitude. Excellent. Look at this. Now we are over Paris with realistic buildings. As you can see, for example, we have this beautiful monument, or I'm looking for Eiffel Tower. Beautiful. Hello. That's it. Okay, and as you can see, the camera can be set with this position 0, 0, 0, and with the rotation of 0. Okay, but the georeference height is 2250. Okay, make it a little bit something like this. No, sorry. For example, set the camera itself. Excuse me. Yes. It is better now. And if I play the scene, come on, baby. All right. We are in Paris. Look at this. It's very beautiful. Excellent. Okay, and even you can you can add some locations for this, settings. In the future, I will teach you how we can do this. But for the Google Photorealistic 3D tiles, here we will have some features to being able to optimize the the scene with our custom options. But the most important part is this guy. You can even, this is really insane, you can even add colliders to the all objects of the earth, of the the whole terrain. This guy, this guy, this guy, these trees can have colliders, physics meshes. It is perfect and it is fully optimistic. Optimized, sorry. So you can have your own train and you can play your game and you can make your game whatever you want, and it is perfect. But remember, by default, it doesn't affect the light doesn't affect on train. It is really important. Let's fix this problem together. After that, we will talk about these options. Okay, in the next step, I will talk about how we can customize this train and fix this lighting problem, and also how we can optimize the rendering side and these options together. Okay, let's go to the next step.